Back everybody, okay, let's look at the question. Question may be very great and about the solution could be somewhat great also, okay, because like the previous question may be great, the solution could be somewhat miniature, but now it's not like that, so question is also great, the answer could be great. What is the formula to answer? Okay, let's look at the question. The energy band diagram, so they give some diagram, okay, and they ask about the density profile, and now they give assumption of NFX, the strong concentration, they give some more expression, okay, this is the expression. And they give alpha value instead of 0.1 V per centimeter, and the x value should be in centimeter. Okay, then a kT by cube. So Boltzmann constant, temperature, charge, and all these calculations will give some value. Okay, I hope everyone knows the answer. This answer, this is a standard one. And after Dn they are given. So d by mu is equal to kT by q. Okay, so from this you can find the mu value. So like this, everything they again they ask about the electron density. Okay, in a bit per centimeter square. Now just look at over here. What I just tell you means, first of all, you got the solution. Okay. And just go to the solution and you find the two things. That means what? Electron density for diffusion and electron density for drift. So what this means is that for a diffusion, what you have, I hope everyone knows that for this we have to represent D. Q will be there, surely is it right? And then afterwards there should be D. So D should be there. Then afterwards D fx divided by, so this we have to integrate. So it's with respect to dx, okay? So that's a simply one, the first one. And afterwards we have to go with the next one, okay? So first, because we know the value of the step of minus 19, and we know the d value is given very directly here. I think the d value is just given here, dn. So small dn of by x divided by dx. We have to find out, okay? So dn of x divided by dx. Now you got to find. So that's good. The formula would be very easy. So what you have this simple value of 10 power of, look at this one here. So this you have differentiate, okay? So constant 10 power of 15. We'll be getting no problem, and then after this you just to find means what you may get this the whole thing. Q alpha by kT will be coming in this one, is it right? Q alpha by kT alpha. So look at out here. You differentiate Q alpha by kT into e power Q alpha x by kT. Now they will be coming. So you know how to calculate this value. Look at out here. So Q by kT we know 1 by 0.026. Okay. So just look at out here. I'm taking this value. Okay here. Q by kT is equal to, so instead of Q by kT, what do you have? 1 divided by 0.026, okay? And for alpha, you can have 0.1. If you do the multiplication, you will get some answer for this one range, and afterwards you can just apply for x equal to 0, okay? Just no problem, just to rub up this one. So I hope you might understand very clearly, right? So I want just to go for solving everything, okay? So directly, I'm going to give the answer of dn by dx, okay? Which is equal to, at the time, so dm by dx at the time, x equal to 0 is equal to 3.846. I give the answer directly because I already solved everything, okay? Into 10 power 15 per centimeter power 4, okay? So no more problem, you got all these values. Now what you do, you just find about the density with respect to diffusion, okay, no problem this one. So this diffusion will be equal to 1.16 to 10 power minus 19 into what's dn given as 36, and then afterwards you just apply it for this one. You can have this 3.846 into 10 power 15. So because my handwriting could be somewhat different, okay? So I hope you can see the things. So you don't want to look at the board. You can, if you follow me very clearly, you can have the good answers, okay? You just do the calculation. So finally, if you do the multiplication, you'll get the answer, okay? The answer could be more standard. So what's the answer represent means 2.2. So this value will be equal to 2.2 into 10 power minus 3, okay? So for J, we had to go for this V per centimeter, no problem. So what I can have, next one, so this one is, sorry, not V, A per centimeter square. Now we got the J diffusion, okay? I just write the sideways. So look at over here, I just write side. So what the side means, J diffusion is equal to 2.2 into 10 power minus 3. Ampere per centimeter square, okay? I hope you might have know the formula. So may I rub this whole thing so that I can go for next one. What's the next one is about the J drift, okay? No problem. I just remove these things. What I do, just remove from here, okay? And now I gotta go for finding out the J drift. So J drift is more easier than to find out the J diffusion. The J drift value, which is equal to, okay, for this one, x equal to 0, okay? So this is J diffusion at x equal to 0. For J drift, which will be equal to the value of n of 0 So the formula over here, Q into Dn, is it right? So J drift means what? What's the Dn? Mu into E. I hope you may know the formula for D. D is equal to mu into epsilon. You don't know the formula, is it right? So this is the formula for electron and electron flux density. So more formula available. So in the place of Dn, you can have the value of mu as well as that of Ex, and then afterwards just write whole this one. So what's the value Q1 Q into Ex? Okay, leave this one. And now you find this answer for this one. What's the mu value? Mu value is also right here. Anyway, it's right here. N value 10 power 15 because n 0 is it right? If you supply 0, e power 0 is 1. N of 0 means what? X is 0. N of 0, n of x, n of x here. N of 0 means what? X will be 0 and the whole term will be getting 1. So you're taking 10 power 15. And enter the mu value you can know 3846. Okay. So 1384.5. 1384.5 mu value you can calculate from here. Okay. Mu is equal to Q into D divided by KT. Okay. So if you do the calculation, now just write it down here. You know, is it right? Mu is equal to, so just write clearly here. Mu equal to, you can know the answer. Q into D divided by KT. Okay. I hope you can see. Take this expression. Mu means right. Mu is here means Q into D divided by KT. All these values are available. Okay. So from this one. So you can find 1 by 0.6 into Dn, which is equal to 36 mm square. In the calculation, you can find 20.45 into the Ex value could be found. Is it right? So Ex will be equal to. So this E value we can find this second line very clearly. Okay. Ex equal to minus this formula minus KT divided by Q into 1 divided by N of X into Dn of X divided by Dx. Okay. If you do the substitution, you'll be getting the answer as minus alpha. Okay, what's the alpha? 0.1. So that's equal to minus 0.1. Okay, and then afterwards you make this value here. So which will be equal to 10 power 15, 1384.5 into minus 0.1 into what? Because I'm just writing very rubbing with it right, no problem. Minus 0.1. Okay. So I hope you might have know the formula for this one. Minus KT by Q into 1 by N of X into Dn of X divided by Dx. Okay. This is the formula for E. So what is the total J means? J diffusion plus J drift. Okay. So right over here, I just write with some red pen. You can understand here. So totally already J diffusion available. Is it right? You can have the value of J drift. What J drift means? J drift equal to minus 2.2 into 10 power minus 3 A per centimeter square. Okay, if you do the calculation, you might have find J drift equal minus 1. What's the total current density is equal to? What's the total current density you might have find? You have to add the J drift as well as that of J diffusion. J is equal to J diffusion plus J drift. So 2.2 plus minus 2.2 is equal to 0. The answer is 0. Option C. Some more confusion, right? Okay, please don't worry. This problem somewhat lengthier because I'm just taking for 8 minutes going on. Don't worry, okay, no problem. If you just redo the sum for 2 or 3 times, it will be a family for you, okay? Thank you all. Thank you very much.